As you may remember, we built a freestanding through cargo, but depending on the operating system. Okay, so this is the target thing, right? So by default, it takes the current target, which on my case here, yesterday on my Mac, it was Apple, Apple Darwin, or Mac OS Apple Darwin. Here it's here it is. Oh, sorry, it was AR64 Apple Darwin. This is x86 64 Linux. No, x86 64 unknown Linux, right? So yeah, the vendor is probably for I don't know OEM installed OSs or something. Cool. So we have the stuff from yesterday. We did it with cargo by doing the hyphen target, and we've passed this random embedded system target, but we can't really do that. So we have to now create our own target. All right. First thing it asked me to do is to install the nightly version of Rust with Rust Hub. I don't know why they asked me to do this. Okay, I think it enables this macro for doing assembly and all that. If it's needed, we'll do it. For now, it's fine. Alright, so this is the x86 target. It has LLVM target, which is the name itself. Linux GNU, by the way. It's GNU. Its GNU stands for GNU. NU. Something like that. I remember that. Or is that no? That is GNU. Alright, data layout. Apparently, this is something that LLVM uses in order to decide the size of pointers and integers and all those things. I think somewhere, right here. Do I remember stuff? Of course, I remember stuff, dude. When you care about something so deeply that your identity is at risk, of course, you're gonna remember stuff. Okay, so we have some stuff here. Some pre-link, the linker args that get passed, then the OS Linux, of course, target pointer, C, int, width, and all that specified. Cool, so we create our own. I'm not going to copy paste. Okay, I'm going to copy paste it. I'm not typing the data layout myself, but let's create this. Alright, so the first thing I'm going to do now is go to the same path as cargo terminal and create a x86 64 hyphen no x86 64 hyphen. Why unknown is not there? I'm going to put unknown, and we're going to have DOS. Alright, I'm going to paste the stuff here, and the rest remains the same. Cool. So we have this. Okay, note we changed the OS to none. Yeah, we did that in this third key right here. Alright, fine. We add the following build related entries: linker flavor with. Oh, this is the entire one. Okay, I think this is a good way to start, right? Let's add one by one. Let's understand what it does and add. I'm not going to add by default. So by default, we have LLVM target. I understand that. We have data layout. I understand that. Arch, fine. OS, fine. Executables, fine. This stuff is a little unclear, but we basically copied it from the Linux one, right? Okay. So it's a standard values for it. Target and little endian, 64 is the width of the pointer, and 32 is the width of the CENT. Cool. Okay, so most fields remain the same, so we just copy this part, right? Alright. Now that we change the OS, we will run very well. Fine. We add the following, which are build related. Alright. So I'm gonna add this. I don't have a JSON linter. Don't tell me I broke JSON. Why? How did I break JSON, dude? This comma is not right. Okay, whatever. Okay, so we add the stuff. So instead of using the default linker, which might not support Linux targets, we use a cross-platform linker, okay? That shipped with Rust itself. Fine. Then, panic strategy abort is the one that we use to disable stack unwinding like yesterday. Alright, do that. This specifies, we know this part, this is fine. Same as, okay, I can remove from our cargo terminal now. Right, I don't need this guy anymore. Cool. What next? Disable red zone true. What is that? Yeah, we can remove from there. Exactly. Cool. Okay. Disable red zone true. We're writing a kernel, so we'll need to handle interrupts at some point. Okay. Yeah, because process interrupts. Okay. To do that safely, we have to disable certain stack pointer optimization called red zone. Fine. Something Rust compiler does that is not suitable for kernel. Disable red zone. It's some pointer optimization apparently. Stack pointer optimization. Okay. It would cause stack corruption. Okay, I do want to read this at some point in the future. Or now. Fine. Then we have some features here. I don't know what that is for. Let's see it, but let's add first. Alright. The features field enables disables target features. We disable MMX and SSE by prefixing them and enables offload. What are these for? I don't know. Okay, MMX and SSE determine support for SIMD. Dude, the terms that are like magical, you know. I feel like if I'm able to get through this, I will feel like the main character from Witcher Atelier. Right? Drawing magic is something that only a few people could do, but you can definitely become one of those people. We can become one of those people. We can become wizards. Alright. Cool. So, these two. Disable SIMD. Or determine support for SIMD. Instructions, which can speed up programs significantly. However, using the large SIMD registers in OS. What is weird music right here? Alright. Not now, dude. It's interesting, but not now. Okay. Okay. Let's read the first part. So, we disable the features by adding a minus. That's cool. We enable by adding a plus. Perfect. So, we enable soft load. We disable MMX and SSE. Alright. So, SIMD can speed up significantly. However, large SIMD registers in OS kernels leads to performance problems. Okay. Fine. It's a trade-off. We don't know how to use it. We don't disable it. The reason is that yet SIMD, whatever. Not now. Not today's thing. The reason is that the kernel needs to restore all registers. What is a register exactly? I don't really know. Let's see. The reason is that the kernel needs to restore all registers to the original state before continuing an interrupted set program. This means that the kernel has to save the complete SIMD state to main memory on each system call or hardware interrupt. Since SIMD, I do not get this part. Bottom line, SIMD state is large. Interrupts can occur very often. The additional things can harm performance. To avoid this, we disable SIMD for our kernel. Only for our kernel. The problem with disabling SIMD is that floating point operations on x86 require SIMD registers by default. To solve this problem, we have the soft float feature. Okay, I kind of at least got that now. Which emulates all floating points operations and software functions based on normal integers. So bottom line SIMD is basically you give multiple data single instructions, some sort of parallelism at the CPU hardware level. Super cool stuff, dude. It's like a forbidden magic, right? Forbidden jutsu. Fine. Again, they have posts on everything. I'm just gonna keep them ready. Right. I can always come back here and find the post. Don't worry about it. Fine. Okay. Then we need this thing over here. I thought the ABI was CABI. Okay, I don't know. Since we want to use this feature, we also need a Rust compiler. Let's see that we want to use the corresponding ABI. We can do that by setting this to x86 soft load. Fine. So we have this. Alright. So now we can compile. Dude, what are you talking about? Alright. I didn't even get the error that they are talking about. Huh? Note that the entry point needs to be called start regardless of your host OS. We can now build a kernel. Okay. Oh yeah, of course this will work, right? I have to give the target as this guy. And I got the JSON target JSON thingy. So what's the thing? It tells us that a custom JSON target specifications are unstable feature finds it needs to be enabled. Is that why we need nightly? No, it's a dot cargo config. I could add it here itself, yeah. Dot, which cargo? Yeah. Vi cargo config toml doesn't exist. Let's add unstable. It's an unstable cargo feature. JSON target spec true. Alright. What next? Okay, this is not the global thingy. I need to have it right here. I don't have it though. This is next to your SRC folder. JSON target spectrum. Let's see. That's the AI. ChatGPT don't want you to do anything. I'm stuck at same JSON unstable error. I feel like every agent thing should have like a chat GPT mode, a chat mode where it doesn't do anything. Oh, I need nightly. Alright. Cool. I don't know what the lyrics are, but it's something the AI has made. Alright. I did this. Oh wait, now it will generate dot cargo, is it? Okay. Should I create an mkdir dot cargo here and create a dot cargo config dot toml. No, dude. Okay. Okay, I installed nightly, created in file in project cargo build same. Performance is fine. Did I miss anything? I have this. Check my cargo config here. I don't want to pass the flag. Exactly. Okay. Oh, okay. Yes, the core library by default only supports valid triples, not ours. You have to add stuff like this. This config is absolutely necessary. How do I make cargo nicely? This is some Rust C stuff. Ah, thank you. Alright. This target cannot be installed, so I'm gonna open the cargo config terminal again, and I'm gonna add this guy. Build build std equal to core compiler build things. Alright. So it's not including the core stuff as a. Alright, that is cool. After setting this, we should be able to compile and delete compile. I'm gonna do a release compile just for the heck of it. Hey, yeah, no. Okay. I thought, do I not have to get this file? I probably do. There must be some cargo terminal that automates that, but fine. Okay, now are we ready to do stuff? We are nowhere near ready to do stuff. But okay, we have compiled.